So personally, thank you to give the opportunity to just present what we did. So the title of the presentation is just what we are doing, trying to delivering robot solution, also using the open source. So about the company, this is the only slide, so I promise that I put, just in order to give you a little bit also the framework about what we are doing. We have 4 different business units. Most of them are based on research, so especially about the humanoid legged system, and also social robotics and mobility. And then we have more industrial part in the intralogistics with the autonomous inventory robot like Stobot that we are selling now everywhere. And for example, with Decathlon, we already entered in 12 countries, more than 100 robots doing maintenance also remotely is what we are doing. And also we are part of a lot of association of robotics. I'm one of the director of robotics, and then also in ISPAROB here, and now I'm the chair industry for IFR, also for the statistic about service robotics. But I would like to give 3 different points. From one side, show you something about hardware that we are using in different projects, then some projects that allow us to improve this hardware, and also giving more solution about software. So speaking about hardware, we already mentioned Tiago. So the Tiago hardware development is a modular and flexible solution that is also with the open source. You will see later on in the next slides. But here you can see the different add-ons that we had for the robots. So the idea is, most of the time, you purchase a platform, not because it's the platform perfect for you, but it's just because you don't have the budget in order to purchase the proper one. So the idea of this modularity also in hardware is to have a robot that could adapt to your research need instead of making the opposite way around. So we already seen a lot of time this kind of behavior. So for this reason, we have a configuration that could adapt also for the different needs. And you can also have configure your own mobile platform with 1 arm, 2 arms, different end effector, different bases. And this is something that we are doing since 2015, more or less. And another hardware that we are using is about the ARI, that is an acronym of artificial robot intelligence. But the idea is to have a robot that could be a social robot. So the idea is about the interaction. And so we are developing different use cases with the robots, like the welcoming, also the dynamic information point, imagine an exhibition, giving, also the guiding inside of a museum. And so we are working on it. And we have different projects and pilots that you will see later on. And the idea is also to have a platform that you can also add different things, not only from software point of view. And now, one part that we are probably will present in the next cycle next year is the new arm development. That is a new arm that will have a serialistic actuator and also have option in the brakes that could help a lot to enter this mobile manipulator also in industry domain, especially thanks to the brakes. And here is some hints that so we will pass through the CAN, so to the EtherCAT, so we will have a stronger, faster loop, and we will have 3 different sides of the rotary actuator that will allow us to have also different sides of the arm. So you can also make smaller or bigger, if is the case. Another things that is going quite well, that is from educational, because from this workshop, there's also the educational part, is we are helping, thanks to the project memo that it was probably you have seen this morning from Olivier, some other video. And so we are helping the production part, because even if this robot is open hardware and open software, it's still a mess to try to build it by yourself. So if you try to take all the different components, it will take probably three months, and you will spend probably the double of the amount that we are just saying. So we are just giving this business in order to to purchase directly the platform. And so we can send directly already mounted robots, or you can mount by yourself, and we have just a kit that you can use it by yourself. But this is not our development, but we are trying to make business around it. Now, passing to another platform that you have extensively seen this morning, also in other presentation, is about Talos. Is one of probably most important torque control robots on the biped side that is fully electrics on EtherCAT, and what we are doing now with the different projects, trying to stabilize the different things about the real challenges that we have in the torque control. So I can't say that we already finished the platform, but it's a research platform. And for this reason, we need also the help of the community in order to improve this kind of solution and make something that is even better for the future. And here you have seen some video where the robot can make a dynamic walking and also quite fast. And also on manipulation, we are using also all the actuation and the torque control in order to make better manipulation. And another platform that we are working based on what we just learned from the Talos developments is the Kangaroo. At the moment, we already built the lower body, so you can see only the legs here. It's a very big challenge because all the transmission here is non-linear, so it's very complicated from also mathematical point of view. And here you can see that there's a low inertia and it's also very, let me say, small and simple design. And so the agility of these robots is the main important part. So you can see that also all the electronics is in the hip and also the motors. And so the idea is to have a dynamic model that could work better than what we have already experimented in the Talos. Here you can see some video, if internet allow us to have this video. And also these are real video with the real platform. And also you can see on the right some jump, also in slow motion with the robot. So obviously, if you see this video, you can see that it's something that we can improve. And it's exactly what we are doing. So this video are already old, probably have more than 6 months, but it's what we are working now in order to make more robust and better. How we can do this? Obviously, we are not doing this alone. So it's thanks to different projects. Here we did a kind of categorization of the different projects that we have. Mainly are European projects, but not only European. I'm not showing here also the internal private project that we have, but here you can have an idea about the different projects that we have in Europe, based on the healthcare, on the agri-food, but mainly also industry and research. So these are the projects that allow us not only to receive funding, that is not our purpose for this kind of collaboration, but is to collaborate with the community in order to develop something together. And so for this reason, in Europe, we are doing this more and more in order to develop the next product for our company. And there's a big gap because in university, there's a lot of things that are doing very well, and in the real world, there's not. And so, in my opinion, company like PAL Robotics has to try to fill this gap. And so for this reason, I just try also to give you an hint about what we learned or how we improved our platform through this project. Here, for example, thanks to the ROS2, we added the ROS2 for control that we already seen this morning a presentation about it, but also the fleet management that is helping us to have the fleet of the robots. And then the new arm design, we also used the canopies project for that. About the social robots, we have a lot of projects in healthcare system. You have seen the previous slide about the collaboration. We had a lot of projects in healthcare. And the idea is to have more and more human-robot interaction. And so this is something that everybody is speaking about, but it's very difficult. At the moment, in my opinion, we are still in early stage. And we are trying to optimize our RE platform in order to do this better and better. Now, I just focus on 3 projects. The first one is OpenDR, because it's about open software. And so we claim to have a platform, a toolkit, where you have already artificial intelligence algorithms trained for the robots. So you will have, if you go to the website, you could have in the GitHub different algorithms already trained. Imagine a kind of open CV where you have already trained the algorithms for these robots. And so you can use it off the shelves. So it's not compared with PTORCH 2, but it's something that you can already use directly because it's already trained. So this is the most important part. And here, there's also the simulator, CyberBotics, the WebOps simulator, that is also defining and helping to make better also from simulator point of view, our robots. The canopy is already explained, that is about the arm. So the idea is to have harvesting robots. So also in agriculture, now it's a big trend because we don't have enough manpower in order to fulfill all the big challenges that nowadays agriculture has. And so they need robots on torque control that can do this. And finally, here is with Universe. And then finally, there's the Agimus project that is just started. So at the moment, I don't have video to show, but the idea is to use the AI-powered agile production. And so to have a robot with the new one that you have seen in the previous slide, in a mobile manipulator that could help in agile production. Now just switch from the software side. Probably you already know that we are using a lot of open software. And here you can see a lot of different logos about what we are using. And the idea is we put on open source the URIDAF model, the controllers, and a lot of tutorials. Here, I put just the list of the tutorial that we did in the ROS. And so if you go to the ROS wiki, you will see that there's a lot of our robots. And so the idea is to not only take in from the community, but also help the community in order to push these kind of things. And also we learned a lot from the community because sometimes we detected that we had something that could be improved and we tried to do it. About the software development, this is not everything open source, but there are also a lot of effort that we are doing from software point of view. And this slide is just to demonstrate to you that with the open source, you can also do business. So just making some packages on top of the open source part, you can also sell some software solution like we are doing. Make an example. For example, the Tiago. You have the Tiago that could navigate. You could use the perception, manipulation, and the interaction in general. If you are very, very good in navigation, you can take it out from ROS, our stack of navigation, use yours. Completely fine for us. You can hack the robot. You can do these kind of things. But if you want to use our advanced navigation stack, we have some fee that, okay, we have also to survive like company. And so a part of this navigation that I just mentioned, there's also impedance control, human-robot interaction. There's something that is open source like ROS for HRI, and some other part no, and then the whole body control. About the simulation, I already mentioned the WebOps, but we have also the classic gazebo simulation that is online. And now we are working hardly with ROS2 control that I already seen this morning, Olivier trying to convince the use of this robot, of this layer, because it's very important for the abstraction in order to be platform independent. And then the nav2 and the move2. So we are working hard also to use more and more the ROS2, because yes, you know that in a couple of years we will have to leave the ROS1 and just pass to ROS2 altogether. From software, I already mentioned some parts that are open source, other not, but one of the main focus that we are trying to address is about the social part. So the social is something that at the moment needs a lot of different inputs. And here you can see one of the important parts is from reasoning, also on semantic knowledge and the agile motion. So we already learned, and we have a lot of clients that sometimes said, okay, why your robot is not going fast? Most of the time is about regulation, but other time is just because of the control, other time is the frequency loop. And so the idea is to try to make it as faster as possible in order to fulfill the real use cases, depending case by case. One of the things that we are doing to our client, for example, is the web GUI. That is a software where you have a different kind of plugins. Imagine this like a framework where you have different plugins where you can use different kind of things, everything web-based. So we don't need to have an expert in robotics in order to use it. And you can easily make a motion builder. Imagine a kind of Adobe Premiere for the robots. The ARI has also a touch screen, so you can have here different kind of things like the touch screen, then the light that you could have in the different robots, and also the movements. And you can also create here the different movements based on the range of the articulation that you can move, and you can do it easily, your execution and your demo in a couple of minutes instead of days. That is what was happening to us some years ago. Here, for example, you have a simple example that you can do this kind of things really in few minutes. And so this is a very good platform. We did also an open source of that is called the Play Motion Builder. You can go on the website, download it and use it, and it's open. Then you have the touch screen manager. So it's just to give you also the interface about how we are using these kind of tools. And so you can trigger different kind of button. You can also add it some HTML that is very important, for example, for exhibition. If we have a robot that go and have to give advertising for different company, you don't have to program it hard on the robot, but you can use easily HTML that you can use in the marketing department, and also making different kind of video which support a lot of codecs, and have a slideshow, easy to use. And finally, the navigation tab that is very useful for the Tiago, but also we are using extensively also in the Stockbot robots. And so it's the background of all the robots where we are doing maintenance all around the world that could be remotely controlled, and you can do different demo with it, with the simple point-to-point stuff, or to the localization, also docking the robot remotely, turn on, turn off, and using like a joystick, making the map, designing the different area that are forbidden or not, and so it's easily to use. And the presentation is what I already said to you. Here is a little bit more graphical what you can do, thanks also to the text-to-speech and also the different motion that is on the library, or you can create by yourself. And finally, the visual programming tabs. This is something that we are working based on the behavior trees. And so it's a kind of blocky where you can program the robots. This is quite important for the business for who would like to use social robots but has no PhD in robotics. So this is quite important for people not expert in robotics to use this kind of blocks in order to work with the robot in easy way. And obviously, what you would like to do is to write your own activities. So to use the robot based on what you would like to implement, to demonstrate, or use case that you want to do. I already mentioned, but here you could have a little better view about the ROS for HRI. This is something that one professor that just joined us 2 years ago, Severin Lemagnan, that is pushing a lot inside the community. We already had a panel in Roscon, and also we had a tutorial in IROS recently, the last month, about the use of these packages. And the idea is to have a similar architecture where you can use HRI with your modules. It's completely open source, so here we are not making money on that. But the idea is to populate this architecture with the different technology that you can see here. From one side, the social perception, so the simple face recognition or a speech recognition. And so you can add, for example, the Google one or whatever you are using. And so in these packages, and from the other side, the social behaviors. So perception and behaviors would be in the same architecture, and so you can use off the shelf the different seeds that you can see here in order to make more robust the human-robot interaction. That is something that would be very useful to make the next steps for the robots. And finally, to close a little bit better, a closer view to the ROS control. So nowadays we are working a lot with ROS control 1, and we are defining the ROS control 2, not alone, but with a lot of big companies also, in order to make something that could be a kind of standard in order to use it all together. And then the PAL statistic frameworks, in my opinion, if you don't know about these packages, take a look on it, because it's very interesting and you can give a lot of statistics off the shelves. And the Play Motion Builder that is set to you, and for sure, all the tutorials that I mentioned before, you can just take a look here with these slides. So based on that, I just pass to the last message that I want to just give to you. So probably I go very fast, so I don't know if I went too fast, but the idea is the message that we would like to transmit is that service robotics is not something that one single company can do. So it's something about collaboration. It's something that will come. And if my vision is that if all the robotics companies in the world just make together all the things, we will not fulfill the real needs that we have now about robotics. So it's time to start working together, start doing the things together, and the open source community is very, very important. It's the key, in my opinion, in order to make more research and to advance faster, and don't reinvent the wheel. And sorry, don't redo this kind of presentation even here. And so just reuse the things that we are doing. And then for sure, we don't have to forget that all customers are different, all use cases are different. And so we have to interact and start working in design or co-design with the client or with the customers from scratch. This is very important. Sometimes also our engineers, sometimes we forgot to do it. And this is not saying, in my opinion, it's very important to do it. But even more important is the passion and the motivation about all the challenges that you will find. So robotics is not easy going at the moment. We are trying to work in order to make it more easier for everybody. But at the moment, without passion and motivation, I think that nothing could be done. So thank you for your attention.
Hey, I think we can have one more question.
It was not technical, so now, okay, that's one question.
Yeah, thank you for the presentation. So one could have the impression actually that a lot of things have been solved, right? So where are we exactly? So can you comment on maybe the limitations of the current systems and whether they are really ready to be used for real world setups and real world scenarios?
Okay, thanks for the question. Real world is always difficult. One of the things that I used to, one of the questions that also I used to put in some exhibition like this is, where are the robots? Here in this room, where is the robot that is interacting? There's no robot. So this is the real problem. The real problem is that we are not using exactly the things. And in my opinion, this is because sometimes there's time constraints. And so from one side, company has to make business, more and more business. So they are focused on business model. And so they forgot all the rest. University or research are going to the research, pushing the limits in order to do something very well. And there's a big gap in the middle. In the middle is a big gap. that is in between research and the real world. And then there's marketing that sometimes you destroy everything because just giving an expectation that then can't be fulfilled. This is my point of view, because if we see a robot that can do whatever like in the movies, then it's not the reality. Even if you put a huge amount of money, I don't think that will solve all the problem. So we are still have to work in a robust way, like the title of my presentation, in order to deliver a solution. And we are here now with solution, and we have to work in order to make improvement on that. This is my point of view.
So, in your service robot, what exactly can the robot do in terms of functionality? Are the actuators strong enough to lift things or feed someone, or is it primarily just zero?
This really depends on the different business units that I mentioned at the beginning. So from the biped robots, the most important part that we did with the Talos, for example, but also with the RMC that I didn't show any picture, but it's a good robots that we are still selling. We don't want to have running, but we will have something robust that could make the things properly. So with the Talos, for example, we have up to 6 kilograms with stretch arms, so it can take up to 6 kilograms. With the Kangaroo, we change a little bit the design in order to have a robot that can jump. Okay, and so this is from research. So we approach on the research side. Then with the Tiago robots, the idea is it was the first business model that we had. It was mainly on research. So I'm giving to the researchers, so to university, also company, a platform that is open source and could be easily hacked in order to make different things. Internally, we did a lot of projects with that. So we have different vertical inside with this part, but the technology is there. What we have seen is that every 1, 2, 3 years, you purchase a new robot. Why? Most of the time, the motors, the actuators are still good, are still the same. You purchase because you have to use a new sensor. Why you don't have the possibility to attach the new sensor, hack the robot, change it in order to don't purchase another platform all the time? And so this was the motivation with Tiago, for example. A similar one with Ari is about price, because it's also very important, because universities sometimes don't have the money in order to purchase this expensive platform, in order to decrease the cost, maintaining the functionality, and giving, with the area especially, the social robotics part. And then from the industrial side, all the navigation that I mentioned, the fleet management is something that they're giving us also the resources in order to invest in the research.